So let's start with the escape velocity. Now, escape velocity is actually the minimum velocity with which a body must be projected up so as to enable it just overcome the gravitational potential. So this is explained that it is the minimum velocity with which a body must be projected up so as to enable it to just overcome the gravitational potential. We need to overcome the gravitational potential to escape from this orbit. Now, this is actually the reverse of the work done. So in this case, we consider the work done to displace a body from the surface of the earth, that is r equal to r, to infinity, that is r equal to infinity. So in this case, we have to do reverse of what we did in the last lecture. So the work done to displace from the surface of earth, we'll be considering it as r equal to r because radius of the earth I have been denoting as r, to infinity. In this case, r will be equal to infinity. Yes. Now we need to define work done in this case. So work done in this case will be, minus is there because we learned that the minus should be here. So in this case, it will be r, it will be infinity, this will be g m, small m, then x square dx. Now this will be, when I solve this will be minus gmm 1 by r infinity to r, sorry, 1 by x minus gmm 1 by infinity minus 1 by, so 1 by infinity will be equal to 0. So this will be equal to minus gmm minus 1 by r. So this will be a positive term, that is gmm over r. So this is the work done, we can say, to displace a body from the surface of earth to infinity. Now our work is to find escape velocity. Now in this case, I would be taking escape velocity as VE. Now, if VE is the required escape velocity, then kinetic energy which should be given to the body is half mve square, and the work done is gmmr. Now, the kinetic energy and the work done is equal, as we need to project the body so as to escape the gravitational pull, is performed by the body by providing an equal amount of kinetic energy to at the surface of the earth. So it must be equal. Kinetic energy and the work done must be equal to have some escape velocity. So this will be, we need to rearrange the terms. So m gets cancelled with small m. So it will be 2 gm over r. So VE will be equal to under root 2 gm r. Now, as you know that gm is nothing but equal to g r square. We'll be putting the value of gm. So it will be 2 gr square. R and R gets cancelled. That is V equal to under root 2 gr. Now, next thing we need to find is in terms of density. So it will be VE under root 2. G will be 4 by 3 pi rho gr cross r. Now this will be, as we have 2r, that means 1 will come out. So it will be 8 by 3 pi rho g. So this will be your final expression for VE. This, if you have G and R, you can use this equation if you have rho and G. So this is all about escape velocity. And one more thing is that escape velocity is independent of mass and direction of projection of the body. So it doesn't depend on the mass of the object. And if you want to calculate for the Earth, it will be very simple. So if we need to find escape velocity for the Earth, so it will be 2 cross 9.8 cross r. R is radius of the Earth, so it will be 6.4 into 10 raised to power 6. So this will be 11.2 kilometer per second. This is very important to know. The escape velocity for Earth is 11.2 kilometer per second. So that's the end for escape velocity. We'll continue with the next topic.